During lockdown, we've been using MathsWatch quite extensively. And while there's a lot to that's good about MathsWatch, I do find that its graphical side, the construction side, can be rather difficult to get your head around. And that's why I've made this short video to look at some issues of construction. I'm going to start quite simply, and then we're going to develop level by level as we go through. So you're welcome to skip ahead to the appropriate bit if you want to, and I'll try and storyboard where we are within this video. So let's start by drawing just a straight line. Well, if I was in class and I said to you draw a line that's 3 centimeters long, you would get out your ruler and a sharp pencil. Well, in MathsWatch, we do something very similar. Now I've called up a question here. Please ignore the fact it says draw an angle. I've just got the page up so that I can demonstrate how we use the tools. So I want a ruler. Well, on the right hand side I have a ruler tool which I can click on and my ruler appears. You'll notice that I can move this around the screen to where I want it to. I can, if I just grab this a minute to show you, this here allows me to rotate it clockwise, anti-clockwise. This allows me to stretch it out. And this one is a measuring tool, and I'll come to that in a moment or two. So if I wanted to make my ruler longer, I would use the arrow there, and I would maybe draw a nice long line. Looks good, and I can move my ruler around. But suppose I want to draw, say, 3 centimeters. Well, in that case, I'm going to use this tool here, and I'm going to pull it, and you'll see it starts to measure for me. And there is 3 centimeters coming up. And now I can just draw along there using the draw tool until we get to 3 centimeters, take it away, and in fact I can just hit that and there are my lovely lines. So that's how we use the ruler tool. What about drawing a circle? Well, in class we would get out our pair of compasses, we'd stick a pencil in, we would line up the point with the end of the pencil lead. But with MathsWatch, a little bit different. Here we go. So I have a compasses tool on the top right. And again, I can drag this around. And you will see that again, we have a number of arrows. This one is to increase the radius of the circle or the arc. This is to make it move up and down, to turn it. And this is the button I'm going to use to draw it with. So if I wanted to make my, say, 3 centimeters, I would move it out to 3. If I don't want to actually draw yet, I want to get a feel for it, I'm going to use this up and down arrow here, and that just moves it around the place. But when I'm ready to draw, I'm going to use this blue, and when I hold it down and move it, then there is my lovely arc, and so forth. Make it a bit shorter so we can see a nice clear circle, and there we go. So I'm starting off with the very simple stuff. When we're done, get rid of the compass, but these are the basics we then build on with our next constructions. So now we're going to go on and look at the third of our key tools, which of course is the protractor. And in MathsWatch, this one is particularly clumsy, so you'll want to pay very careful attention. So I want my protractor tool, which is over here. And with the protractor, you will notice when you play with it that there are 2 circles. I have a blue circle on the left-hand side that I can move, and that reveals a yellow circle behind it. And you will see that as I move the blue circle, it tells me the angle between the 2 lines, the blue and the yellow. So for example, here, 62 degrees is between this line, and that's my angle. If I wanted 90 degrees, I would move this up to there, try and get lined up, and then that would be my right angle. And the other thing that's interesting on this is that there is a small padlock shape. Now if you click on the padlock, it changes color, and that means that when you drag the blue, the entire protractor drags, and that can be quite a useful tool. So let's start again. Imagine I was asked to draw an angle down here of 56 degrees. And that isn't what the question says, but 56 degrees just here, like that. Well, I would grab my protractor. I would move it so that that central point, that's this point here, the middle of the protractor, is right on the end of my line. Just line it up nicely. And then I would move it to 56 degrees. And now I want to mark that, and I'll probably take my little pen tool. I'm going to mark just there is where my line should be. I'm going to remove my protractor. I'll grab my ruler, and then I'm going to draw a line from here, from the end of A through that point there, and hopefully that should be 56 degrees. Now I've actually gone slightly off there, so let me just try that one again. So make sure I'm lined up exactly with my ruler, and that hopefully is a good 56 degrees. And if I want to check that, bring my protractor in, line it up, and you can see that it does indeed line up. Now the same is true if I was going to do, say, an obtuse angle. Let's just get rid of all of that. And if I want an obtuse angle at BAC, then I would set it up here, turn to my angle, say 120 degrees. Where are we there? Mark it with a little X, take away the protractor, and use the ruler to draw that line, and so forth. Now where it gets difficult is this question actually says draw angle ABC. And I wonder if you can see where the problem is. Because ABC would be going A to B to C. And I need an angle looks like this. So if I go over here and add on ABC and try and do 56 degrees, I notice that actually it's going the wrong way. It should be going A, B, C, like this. That angle is like an obtuse angle. It's actually going to be, what, 124 degrees, all of this. So the protractor, I need to be able to flip it over, but I can't do that. So this is one of the secrets with MathsWatch. Again, remember that little lock button? I'm going to click on that lock button, and I'm going to keep that angle at 56. And when I do that, I can now shift the entire, rotate around the entire protractor, line up the blue along this baseline, and now this angle here is 56 degrees. I'm going to, as before, draw my X just there, take away my protractor, and I can use my ruler and I can draw that line. You may need to practice that a little bit, but that is one of the weaknesses in MathsWatch, but that's roughly what it should be doing and how we would draw those lines. So we're going to extend that a bit further, and rather than just drawing one angle, can I construct a triangle where I have one side and I have the other two angles? Well, I'm going to use my protractor for that. And here's my question. Draw ABC. AB is the length 4.2. It's done already. Angle CAB is 56 degrees. Angle ABC is 37 degrees. Well, let's grab my protractor, first of all. And first thing I'm going to do is I'm going to do the simpler one, because I reckon that ABC, if I just grab that to show you, A to B to C, that's going to be my nice acute angle, and my protractor is already set up for that. So let's move my protractor down to the end of the line for B. And then having done that, I'm going to move it. I want ABC to be 37 degrees, and I'm going to find 37. Oops, and there we go. I'm going to mark that with an X, just there, and then I'm going to grab my ruler. I'm going to move it to the end, going to spin it around, and now I actually want to make it a bit longer, so let's make it as long as that. And the nice thing about these sort of question is often they want you to leave construction lines in, so I'll leave the X in, I'll leave the line in, and then the other end it says my angle has to be C to A to B, so that's C to A to B, has to be 56 degrees. And as I showed before, that's a bit more problematic. So I'm going to start by moving to the end of that line at point A, finding 56 degrees, there it is, and then because that's my sort of obtuse angle, if you like, I'm going to lock that, and now it's locked, I can spin it around, line up the blue with my baseline, and I can mark a point just there. I take that away, I can then use my ruler and line that up with the end of line AB, going through the point, make it a bit longer, and there should be my lovely triangle. So that's how we do questions like this. You might want to practice it. Again, this is just taken from the questions associated with clip 47, but hopefully that makes a bit more sense. So our next construction is to draw a triangle using only a ruler and compasses. Well, let's try one of those questions. So here, draw ABC. AB's length 4.5. It's already done for me. AC should be 3 centimeters. BC 3.5 centimeters. I need to use my compasses. It says use a compass, so I'm going to do that. I'm going to grab my compasses first of all. Here we go. Oh, and I'm going to start that A to C is 3 centimeters. So let me extend my compasses to give me 3 centimeters, just like that. And then I'm going to move that to the end of AB, and then I'm going to draw an arc like this, because I don't yet know where the line A to C and B to C is going to meet. I don't know that yet, but I'll draw an arc to give me a feel for that. And now I'm told that B to C is 3.5 centimeters. So I'm going to move my compasses to the end of AB. Just turn it around a little bit. Need to make it a bit longer, make it up to 3.5. And now I'm going to draw another arc. This one's got radius 3.5. And having drawn that and seeing that they intersect, I'm going to just remove my compasses, and basically this will be point C. I know that A to C must be 3 centimeters because this was a radius of 3. I know that B to C must be 3.5 centimeters because that is a radius of 3.5. So I'll grab my ruler and I will connect up these two lines. So I'm going to first of all draw my ruler. I'm going to make sure it lines up with that point. Just about there. Draw my line there. It doesn't matter if I draw too far. Go over to the other end of B. Turn my ruler, turn my ruler around so that it's again going to go through that point. Get it exact, and then draw my line there. Take away the ruler, and there you can see A to B to C. Now if I wanted to, I could even take the ruler and I could measure A to C, but actually I know that it's going to be all right. So that's a little bit of practice, but it's well worth putting that practice in. The next construction has to do with measuring and drawing a bearing. If you haven't yet looked at bearings, then this may be a little bit new to you, but the principles of how we use the tools are the same. So here I have points A and B, and I want to measure the bearing from A to B. First thing I'm going to do is I'm going to draw a line between A and B. So there's A and there is B, and there is my line. Now, with bearings, we need to measure everything from north. So what I'm going to do is I'm going to take my protractor, I'm going to move my compasses, sorry, my protractor, so it's right on A, and I want to know where is my north. I'm going to move my blue, oops, I'm going to move my blue up to 90, and then grab my pen and use that to mark that is north from A. And there it is. And now I'm going to do exactly the same thing for B, because I need to know where is due north from B. And there is my X. I think it actually worked. I'm off the screen. So hopefully that will have given me my points. So I now need to know the angles between north. So what I'm going to do is I'm going to draw those. I'm going to grab my ruler. I'm just going to spin it around so it's going north. And I'm going to just connect up those 2 points. So that's my north line there. And hopefully that will be my north line there. So when it comes to bearings, this is really, really important. So now I want to know the bearing of B from A. I'm starting at A. I'm looking towards B. So I want to measure this angle here. Well, how do I do that? Well, let's go back to here. And I'm going to start by locking my protractor. So I lock it because I want to measure not from the horizontal, but from the vertical line. So I'm going to go to A again. I'm going to spin both of them round until they both line up with the north line. And now I'm going to unlock them. And having unlocked them, I can now move my blue circle and it's measuring this angle here, which is what I'm looking for. And if I go down there, I can measure and I can see that's approximately 7 degrees. So I would write 070 because I remember that this is a 3-figure bearing. Do the same B from A. So that's starting at B, going towards A. Then I will again move my protractor, get it right, won't I? To B. And this time I'm measuring clockwise all the way around to here. So that actually is giving me a bit of a funny angle, isn't it? It's been a little bit difficult. I know this bit is 180. So I want to measure this, but actually it's giving me a negative. So in that case, what I'm going to do, I know this is 180. I'm going to lock it again and spin this around just to there. And now I want to get, oops, it didn't work. I beg your pardon. Just try that one again. I'm there at north. I'm going to unlock it. And then this will give me my angle there. So it's 180 plus another 70 degrees. I can work that out actually because I know that that is my my alternate angles. but it's going to be 180 plus 70, and that would be 250. So again, MathsWatch really is quite cumbersome when it comes using protractors. I'm sorry about that. It's just one of those limitations. So you may need to play around a little bit with locking it and unlocking it, but the key thing is to draw those north lines so we know what we're measuring against. And because bearings are problematic, let me just do another one for you. So we want to find, we're told to find the university is on a bearing of 070 from the stadium and 280 from the hospital. Mark the position of university on the map with a cross. So I want to find, first of all, my north. So I'm going to grab my compasses. I'm going to move them to the stadium. I'm going to go up to 90 degrees. So I know that this is my north. And I want to construct some lines going through north. Is that gone there? I'm not sure it has. Yep, that's gone there. And then do the same for the hospital. I'm going to construct my lines just there. So take away the protractor. And now I need to use my ruler. And I want to make sure that that is going to go north for me. It's not quite lined up. That looks better. So there is my north line there, and there is my north line there. And then having done that, I need to find a bearing of 070 from the stadium. So again, I'm going to grab my my protractor, start it off at 90 degrees. I'm just going to lock that, and I'm going to twist it around so that the yellow I know is now lined up with that. And I'm going to unlock it, and I want to find 070. So 070 looks like that. So let's grab my ruler and let's line it up with here. Twist it around so it goes along the line of that, and we can draw our line along there. Same thing, I'm told its stadium is 280, so I'm going to go over here. Now this one's a little bit more problematic because it's 280 and this calculator, this protractor isn't allowing me to do that. So again, I'm going to go down to 180. I'm going to lock that, I'm going to spin it around. So I know that that angle is going to be 180. I need to get another 100 degrees. So if I then unlock that, then another 100 degrees is going to be just there. So I can grab my ruler and let's just spin it around a bit so it doesn't fall off the edge. And going from there to 100 degrees should look approximately like that. Take away the ruler, and where it is, take away the protractor. This point here should be my place for the university. So it's on a bearing of 070 from the stadium. It's on a bearing of 280, so going there all the way around should be 280, and that should be my university, which I've marked with an X. So that is quite complex, but if you watch the videos a few more times, hopefully it will make a little bit more sense. So our next construction task is to construct a perpendicular bisector, and this is really, really useful when it comes to work on loci. Suppose you have a question like this. The temptation is to grab a ruler and find the midpoint, spin it around and say that looks like about a perpendicular, and I'll just done. Okay, question done. Thank you very much. Especially if it's on squared paper. Unfortunately, in your exam, you will get 0 marks for that. And the reason you'll get 0 marks is that you are required to show your construction marks. So how do I bisect AB? Well, if you watch the video on YouTube or on MathsWatch, it'll help you make sense of that. But basically, I use my my compasses. I start by moving them onto the end of A. I'm going to turn this, and I want actually to touch B. Don't necessarily have to touch B, but I'm going to choose to do that. And then I'm going to draw an arc that goes like that. And then I'm going to go and draw the same arc. And actually, I find that I have a problem with MathsWatch here. It's gone off, so I'm going to just redo that one. And let's have a shorter arc, because obviously on ordinary paper there wouldn't be a problem. Let's go for, say, a 2 centimeter arc. And there is my arc there. I'm going to draw the same arc over here. And if I then draw 2 centimeters from there, I will find that this point is 2 centimeters from A and 2 centimeters from B. And this point is 2 centimeters from A and 2 centimeters from B. So what I'm going to do is draw a line through there. So I grab my ruler. I start there. I'm going to make it stretch through there. Maybe make it a little bit longer perhaps. And that should be my perpendicular bisector. So there she is. Take away the ruler and hopefully you can see that that does look perpendicular, and any point along there is going to be actually an equal distance from A to B, which is really useful when it comes to our loci. But for now, we know that this is half of the length AB, that's half of AB, and it is perpendicular. And then our last main construction technique is to bisect an angle. And here we're asked to use ruler and compasses to bisect the angle PQR. Now again, you could cheat. You could grab your compasses, you could try to measure that angle, you could spin it around and try to work out what this is here, and then measure half of it and draw the line. Unfortunately, if you did that, you would get no points because you have to use your construction marks. So what do? We grab a pair of compasses, and I'm going to stick to 2 centimeters just for now, it's fine. I start by marking, put my compasses on Q there, and I'm going to draw a small arc along P and a small arc along Q, along R. And what I'm doing there is, you will see, is I have created a situation whereby this is 2 centimeters from Q and this is 2 centimeters from R. And what I want to do now is, keeping my radii the same, I'm going to move to that little mark I've made, and I'm going to draw another arc just here. And then I'm going to go to the mark I made down here on QR. I'm going to make another arc, and I'm going to see where they connect. Now, if you look at this, if you actually think about this, I have, this is 2, this is 2, this is 2, and this is 2. And in effect, what I've made is a rhombus. From there to there to there to there is a 2 by 2 by 2 by 2 sided rhombus. And one of the features of a rhombus is that the diagonals bisect. So I'm going to grab my ruler. I'm going to start it at Q. I'm going to go extend it a bit more. so that it goes through that point there. And now if I draw it, oops, let's move it out of the way. If I then draw that line, then I can see that that is bisecting my angle. That is half of this, and this is half of that. And we need to see those construction marks in the exam, or else if you just draw me a line by itself, you won't get any marks at all. And then finally, if you move on to some work on loci, you will be using these various construction tools. I'll just do a couple very, very quickly. So we have a scale drawing of a garden. Tim wants to plant a tree. According to this rules, it must be 4 meters from A and 7 meters from C. Place across where he can plant the tree. So how am I going to do that? Well, one way of doing it is to use my compasses, because I know that it has to be 4 meters from A. Well, I know that 1 centimeter represents 2 meters. So 4 meters on this scale must be 2 centimeters. My compass is already set for that. So I know if I mark down here that that arc, anywhere along that arc, is going to be 2 centimeters, or therefore 4 meters away from A. I'm told that it's 7 meters from C. Well, 7 meters is going to be represented by 3.5 centimeters. Let's just move that on my compasses. I'm going to just spin that around a little bit. Move that on to C. And you see there, if I move the compasses, that they would cross down here, but that's outside the garden, and they cross just here. So this point here, if I mark with an X there, that is going to be 4 meters from A. That's going to be 7 meters from C, and that's the one place where he can plant his tree. So your loci question will use lots of those construction tools. Here's just one more. So here we're told that Adam Ant walks, so he's always the same distance from crumb A and crumb B. So for example, if we were here, he would be the same distance. I can get a feel that if I was to move there, it would also be the same distance. That would be the same distance. That would be the same distance. And I get a feeling that actually what I'm doing here is I'm doing a straight line where it's always the same distance. And if I'm doing a straight line, then essentially I need a perpendicular bisector. It's one of my tools. So I'm going to start by drawing a line between A and B, just so I can visualize that more clearly. So there's my line. And now I'm going to grab my my compasses. I'm going to put 1 on A, and I'm going to draw my arc there. I'm going to put the other end of it on B. I'm going to just swing it around a little bit, and I'm going to mark that there. And where they intersect, I know is going to be my perpendicular bisector. So I grab my ruler, I move it onto here, I spin it around, make it a little bit longer, make sure the line is up properly. And once I'm lined up, not quite lined up there, once I'm lined up, then I don't think I'm quite there actually. That looks better. Then that should be my perpendicular bisector, and therefore anywhere along here the ant will be an equal distance from A and from B. So we're using those techniques to make sure that we can find our loci. And there's lots more practice that you can do with your teacher, but this is just to help you to be confident in how we do this stuff. Thanks for listening. I hope it was helpful. If I make the odd mistake, it's because we all make mistakes in mathematics, but do keep practicing until you can get it right consistently.